First cone you keep it. So this is basically the system B. Okay, it's written there, system B. So they can ask you used for what. You place one single cone inside this, okay, and you condense it. It's condensed in such a way that you get this much portion. Remaining portion, what you do? This portion you just use either the thermoplastic, which you're going to study next, or you can use the warm vertical in itself. Okay. Hi all of you, welcome back for the endodontics lecture. And the next topic I'm going to discuss with you is obturation techniques. Okay, obturation techniques. And there are various obturation techniques using gutta percha. Using what? Using gutta percha. Majorly we have to study, and yes, many of these techniques can be modified for other obturating materials. Fine. So let us discuss the various techniques. So broadly, they are classified into different types. So I'll first discuss with you the types and then I'll come to one by one. Okay. So first one is lateral condensation, which you all do by your hand instrument. Okay, laterally condensing it. Then you have got, there is a warm lateral condensation. So this is cold lateral. You can call it as lateral condensation as such. Then there is a warm vertical. Okay, warm vertical condensation. Then you have got a modification of this warm vertical condensation, which is continuous wave condensation. So this warm vertical is an interrupted. Just learn it like that. So the next one is continuous. Okay, modification of vertical, which is not interrupted, as a continuous wave of condensation technique. Then you've got the thermoplastic, the liquefied form of the, or injecting it into the gutta percha into the canal. Okay, the thermoplastic. Then you have got carrier based. Okay, I think this will be new to you. Carrier based, and then you have got thermomechanical. Okay, there is thermoplastic and thermomechanical compaction techniques, and then you have got a solvent based techniques. And yes, we'll come to them. Then they have paste based, and there is immediate obturation. So let us come on to the first type, which is lateral condensation. Basically, this is a method you all follow with in your colleges and all, which is master apical cone is placed. Okay, master cone is placed, and then you place accessory cone around it. Okay, you place a master cone, then accessory cone around it. So how do you do it? You do it, or how do you place the accessory cones? By inserting the spreaders. Okay, inserting and just condensing it laterally. Okay, so that is using a spreader. Okay, now if you use a warm spreader, it's called a warm lateral condensation. We'll come to this, a little bit details is required. We'll come to this later on. Okay, so that's the warm vertical, warm lateral. Okay, now the spreader, where do you place the spreader? You have to place it within 1 millimeter of working length. So it is, if the working length is 21 millimeters, you place the spreader should reach up to 20 millimeters. 1 millimeter away from the working length, or within 1 mm of working length. Okay. Now, how is your pressure applied? What's the name of the technique? Lateral condensation. So is the pressure applied laterally? No, the pressure applied is in the vertical direction only. You place a master cone and you apply pressure in the vertical direction only. You can't apply pressure in a lateral direction. Why? Because lateral pressure can break the spreader. One big problem. You can't place lateral, though the technique is it's called a lateral condensation, because though you're applying a pressure in a vertical direction, the accessory cone is moving in a lateral direction. Okay, but you have to apply the pressure in that apical or vertical direction, not in a lateral direction, because lateral pressure can break the spreader. So this can confuse you. Okay, they can ask you, in lateral condensation technique, the pressure is applied where? In an apical direction. Now if they change the method of question, in lateral condensation technique, the accessory cones are condensed where? Laterally or apically? Laterally. Okay, but the pressure is applied in an apical direction. Okay, now also there is if you are applying a lateral pressure, you can break the root or you can fracture the root. Okay, now going further, the pressure is maintained for how long? 20 seconds. Okay, just apply pressure, maintain it for 20 seconds, then remove it. I seen people doing it simply just next. Maintain the pressure for 20 seconds. And one more thing, the final cone is not condensed. The final accessory cone is not condensed. Remember that. Why? Because it can lead to spreader track. You place, imagine you're placing the master cone and, for example, 5 accessory cones. So after first accessory cone you condense it, second accessory cone you condense it, third, fourth, after fifth no condensation, because otherwise you'll leave a tract of the spreader, which can, what's the problem? It can contribute to leakage. Okay, I've seen people doing it even after the last cone placed, they just condense it. No, after the last cone being placed, don't condense it, is what they're saying, to avoid the what? Leakage. Okay, so that there is no spreader tract. Okay, so that's about the lateral condensation. So this image, okay, this image, this is a spreader, the blue one is a spreader, and the first master cone is placed, you just condense it. Okay, then the next accessory and so on, and finally you get the final this thing. So if imagine you're getting this kind of a picture in exam, don't worry, just see the spreader there and there is nothing else. Okay, and you get the final condensation, and that is, it's called the lateral condensation method. So basically in lateral condensation, nothing, just using the spreader, and then how you are applying the pressure, that's very important, in an apical direction, and maintaining the pressure for 20 seconds, and don't condense the last cone, final cone. In the options they can give you like this. Okay, final cone is condensed, is not condensed, like that. Or they can use final cone is condensed with a 20 seconds pressure. Is it true or false? It's false. Final cone is not condensed. To avoid, no, again that's a question. You're not condensing it because to avoid micro leakage or spreader tract formation. Now the next method we're going to discuss is warm vertical condensation. So we studied lateral, there is a warm lateral, I'll come to that, then there is a warm vertical. Okay, there is no direct vertical, because to condense it vertically you have to warm it. Okay, to condense the GP vertically you have to warm it. Now it is introduced by a person called Schilder. Okay, Schilder, many people will be, those who know details about endodontics will be familiar with this guy, that is Schilder. Okay, now GP cone is heat softened here. Okay, that is the warm, that is GP cone is heat softened, and what we do is we use heated instruments. Okay, that is an older technique. Now you use some devices. So you use heated instrument. What kind of heated instruments do you use? You mostly use a plugger. Okay, you use mostly a plugger, or you can also use a spreader. Plugger is more commonly used. I'll show you the pluggers, which has got much more broader tip. Okay, so plugger or spreader is used, and they are packed vertically. Okay, they're packed vertically, not laterally. Lateral condensation, the accessory cones are packed laterally. They are packed vertically here, and thus they say that they fill the root canal in 3 dimension, even going into the accessory canals. Not as good as some other techniques, but yes, definitely it can fill. It has the potential to fill the root canal in 3 dimensions. So they can ask you, all of the following fills the root canal in 3 dimensions, except definitely lateral compaction methods, especially the cold lateral compaction method doesn't fill it in a 3 dimension, because it can't fill the accessory canals. Whenever it is warmed, then only it can go into the accessory canals. Understandable, isn't it? Now the thermal conductivity, the conductivity of the heat through the GP cone occurs over a range of 2 to 3 mm. So if you are heating, this is a GP cone, you are heating here, 2 to 3 mm will be, so the 3 mm from there will also be hot. Okay, that's what it is called, 2 to 3 mm thermal conductivity. And thus the rise in GP temperature, GP cone temperature rises. How much? At the apex. So you're condensing the last 2 to 3 mm, just imagine. Okay, or the last 2 to 3 mm you're condensing from top. So what is the temperature at the last 2 to 3 mm is what they're saying, the rise in GP temperature, which is seen as when you just take the plugger and keep it here, how much is the temperature, rise in temperature at the apex. So which is about 3 to 8 degrees Celsius above the body temperature overall, which is usually 40 to 45. So the rise in temperature is how much? They can ask you an MCQ, 40 to 45 degrees Celsius for the heat. So the technique is basically what? The technique is down packing, okay, and backfilling, packing it down and filling it above. Okay, so down packing, backfilling. And this is compared to the next technique which you're going to study is continuous wave compaction technique. This is interrupted. Okay, interrupted in between, small segments is placed, whereas in continuous wave it's continuously being packed. Okay, you will see that. Okay, just understand. So what is very important here is warm vertical is interrupted. Okay, the technique is basically same for warm vertical and the continuous. It's down pack and backfill, but here it is interrupted. There it is going to be a continuous method. Okay, now we said you can use plugger or spreader. Is there any other method which can make it much more easier and much more safer? Yes, there are other sources for applying heat. It is touch and heat. Okay, the name of the device is touch and heat. Touch and heat, easy. EI down pack, again we are using it in other technique also. EI down pack. System B, again you will see there's many other techniques to come. So it's other sources which, you know, it permits temperature control. You're heating it in the flame, you're not going to get a temperature control or the heat control, whereas the device you can set the heat. Okay, so they can ask you all of the following are used in warm vertical except, so touch and heat, EI down pack, system B, they will say Obtura 3 for example, which is not used. Okay, so that's one thing you have to learn here. Now, how is the compacting force? What are the compacting force in lateral condensation? Vertical. Here also it's vertical. Okay, only thing is the methodology of compaction is different. There it is laterally, here it is vertically, it is compacting. Okay, now the maximal temperature you see 0 to 2 mm from the apex, that means in the apical region. How much is the maximum temperature noticed? 44 degrees Celsius. Okay, so we saw here it is around 44, 45. Okay, 44 to 45. So the same thing, the maximum temperature, they can ask you the maximum temperature at the apex, which you can see while the warm vertical compaction is 44 degrees Celsius. Now one more thing, which is much more crucial, is the critical level of root surface. So here it was apex. How much is the root surface of the root? Because you are heating within the root canal, how much is the temperature at the apex? That's what, okay, just take this as a root. How much is the temperature at the surface here? When you are heating it inside, how much is the root surface temperature? Okay, the critical level of root surface temperature which is required or which will produce an irreversible bone damage, because outside the root you have bone. So if there is a root surface temperature very high, it can damage the bones. How much is that? That is any temperature greater than 10 degrees Celsius can damage the bone. Okay, any amount, like if it is 11 degrees Celsius on the outer surface of the root, it can damage the bone. Okay, that is what they are talking about. So remember that. Okay, so this in itself is an MCQ. That is the critical level of root surface temperature or heat. That is the critical level of root surface heat which is required to produce an irreversible bone damage is how much? Greater than 10 degrees Celsius. Okay, now you see this when you're using a plugger or in touch and heat. Okay, in touch and heat, and it is not